Happy Saturday, everyone. Man, this has been a horrible week for work. It's been a lot of driving, a lot of lightning strikes, intense heat, and now I get to burn my weekend making videos because I haven't had time this weekend. This has been sitting under that for about a month and a half. So it's about time to get some stuff caught up here and get moving with these videos, right? So I have something here from Rigexpert, okay? Now, Rigexpert, if you haven't known, they make awesome antenna analyzers. These are a Ukrainian-based company, and man, Ukraine's dealt with a lot of crap in the last year and a half, but they continue to make some great stuff here for antenna analyzers for not only ham radio, because I use this in some commercial applications to check some antennas and feed lines with a TDR and everything else. Got some great stuff. This is the AA2000 Zoom, their flagship, best of the best analyzer. Rigexpert sent me that years ago, and I use it all the time. But then someone says, what does the Rigexpert Tokenblauser do? What is, and I hope I'm saying that right, Tokenblauser? Well, it's not an antenna analyzer, but I took this opportunity to borrow this from gigaparts.com, who also said, Eric, if you want to make a video on that, we'd love to hear what you have to say about it. I got some great information because I use something not like this, but I maintain equipment out in the field that does the same thing this does. And we're going to tell you about this right now and try to give you an answer. I won't be showing you it in use. I'm going to give you some great explanations, and you're going to understand what this does by the end of the video, I promise you. Now, the Rigexpert Tokenblauser is a GPSDO. That's a Global Positioning System Discriminated Oscillator. And that, okay, when you want the actual, the most accurate time base and frequency, it's GPS based, all right? For instance, those like myself who've been building the stuff back here in my backyard to do moon balance on JT9, right? Or let's go back to people that use FT8. You know what FT8 is. And you know FT8, you have to have a very calibrated clock on your computer so that your radio transmits at this specific time and then receives at this specific time, because you don't want to be transmitting, a second too late or a second too early or whatever. Or how about people like me, moon bounce, who want to use JT9 or JT65 to go to the moon and back, okay? You have to calibrate and compensate for the time delay from here to the moon and back. And then the other person on the other side of the world has to be calibrated, because you don't want to be transmitting, it takes what, a second there and a second back. So now you're already 2 seconds off. How do you calibrate your time and your frequency base most accurately? With this, okay? Now, this is what they say is laboratory grade. And basically, this device with this antenna, and you can see this is not open, so I'm going to open this side, all right? Because I know Gigaparts let me borrow this, but now what they're going to do is they're going to sell this as a open box and take some money off, which is cool. Which is where I buy a lot of my stuff, is open box on the used equipment stuff. Like you see here, Gigaparts does a great job. I send it back just the way it was. They look at it, then they'll put it up for open box. Here is the GPS antenna. This looks kind of like a regular GPS antenna, like a hockey puck style. And basically this is going to screw onto this, all right, right here. And then you're going to power it. And what's going to happen is you have 4 outputs here. And each output can be tuned for different reference clocks, all right? So what it's going to do in a nutshell is it's going to get the most accurate time and the accurate frequency. Like, for instance, the 10 megahertz here on the back with the BNC. Have you ever noticed, look on the back of your radio right now, you might have a 9700, you might have a what's it called? Not a flex, but a Anon 200 or Anon 100, right? I'm still drawing a blank on the Apache Labs. There you go. What is that 10 megahertz for? Well, if you want to calibrate more accurately than your TCXO, which is a temperature, let's see, TXCO, temperature compensated crystal oscillator. I think that's what it's called. And if you want it to be absolutely perfect on frequency, that's what the 10 megahertz input is. And this is what the 10 megahertz output is. You're going to feed that in there and you can calibrate it right on for that 10 megahertz. And that, they use 10 megahertz for various reasons. We'll get into that. But like the ICOM 9700 has a 10 megahertz input. And what is that for? Oh my gosh, is that for another band? No, that's to calibrate, because you may be using that ICOM 9700 for something like weak signal modes or whisper or FT8 or JS8 call or even moon bounce or satellites, right? In my field of work, we would use a GPS clock for timing for T1s across the entire state. Now, those T1s, and for simulcast or multicast across an entire, let's say you have something like SARnet, right? And you key up on a repeater in Miami. Well, there's like 30-something repeaters across the Florida, right? Every one of those repeaters has to know when you key up and when they should be transmitting, so that all the voices or the output and the output data is the same time. And then when someone unkeys, they all synchronously drop at the same time. You understand what I'm saying? How do you do that? How do you compensate for the delay in multiple hops across a state and get the same result from this side to this side? You calibrate and you compensate for differences in timing offsets across different networks. And that's when we used GPS clocks, because T1s, by the time you go from here to here, you may have 40 or 80 or 200 milliseconds of delay. That can cause havoc on a network where there's 40 repeaters. Something like this is a lot smaller version of what I'll show you right now as an example of a clock, which is a big professional grade clock that you would use that took GPS data and outputted so that all these T1s were at the exact same time across an entire state. So you take a look at this. This is a Laris clock. And basically what this would do is take a GPS input, which I'll show you on the back, and it would give you the most accurate timing for, in this situation, T1s. All right, and on the back here, you'd see that you'd have a card here, output T1 or E1, right? And you can get other cards in here to do various things. It did have Ethernet connectivity, and here's your 5 or 10 megahertz input, clock in. So you put your GPS antenna on here, and the birds will give it the most accurate time. Now, something like this wouldn't really be practical. It's a negative 48 volt DC. Something like this wouldn't really be practical. They have various options like this back in the day. These are pretty much obsolete at this point. And something like I'm showing you now would, replace something like this. But this is, what I'm showing you is the Tokenblauser is not something someone came up with. This stuff exists. It's just that this is more of a industry grade, and the other one is more of a consumer grade for what we do on radio. Here is another version made by Laris. This is a local remote terminal synchronization timing system. And basically, again, with all the, aside from all this, basically you would, God, it's hot out here. You would input your antenna here, and you get outputs, inputs, outputs. Basically, this can also, work as a remote clock for something downstream. Instead of having one of these at every single site, you'd put this at a main site, and then you could have, several sites, coordinate sites, with remote clocks, which would take this timing over the network and deliver an accurate time base at a distant end without having to have one of these at every single one. So again, obsolete in this day and age, something that is not even used anymore, but and this was industry grade, telco grade, telecom grade, whereas the one I'm showing you is more of a consumer grade. But you wouldn't want something like this, man, right? You wouldn't want something like this, and it probably wouldn't even give you the outputs that you're looking for compared to the Tokenblauser. All right, so this is a lot more affordable and a lot more practical to have, all right? And there's a lot of, I'm gonna reference, hold on one second. So I'm going to reference what Jim Allen had taught me about this, because I asked him some pointers on what he does with a GPS time base. And he gave me some ideas. So I'm going to tell you right here in the email. So it's a GPS-based frequency standard. These can be used to sync radio's transmit and receive frequency at a much higher stability than the standard TCXO. So I said TXO, TCXO. Okay. Some uses for this is when using an HF transceiver with a transverter for VHF, UHF, SHF operations. So let's say you have a transverter and you're using a 10-meter radio, right? And you got a transverter from 900 megahertz. So there's some frequency calibrations that need to be done. Maybe your transverter is just not 100% accurate. This you could use to tune it. When you have exactly 10 megahertz right here, you can tune your radio exactly for 10 megahertz. Now I could take my IFR service monitor and generate 10 megahertz or use that as a 10 megahertz reference, but who's to say that's not out of calibration? You understand? What do the lab techs do to calibrate my device to make sure it is spot on? Well, they got devices that are GPS based to calibrate their test gear, which used to calibrate my test gear, which then I would use to calibrate my radio. At some point, there has to be a perfect frequency and a perfect base to calibrate something on. You understand? So we'll go back to Jim's email here. Where this device differs from other GPS-based references, most are based on a 5 or 10 megahertz reference output. This unit allows you to configure your reference output. Each of the 4 outputs on the back can be individually set to a different reference output frequency from 16 kilohertz to 200 megahertz. So if you have a 10 megahertz input on your radio, or maybe you don't, maybe your device needs a 200 kilohertz reference input, this can do that. So unfortunately, some devices use a 10 megahertz and that's it. That's why 4 of these can be set for 4 different references, okay? That's what's cool about this. As I mentioned, I run a GPS 10 megahertz time base here to provide lab stability with my LMR test equipment. While most amateurs would not have a need for these, those operating satellite and VHF, UHF, and even SHF operations with a transverter would have a need, because you may be 200 kilohertz, 400 kilohertz off by the time you go from 28 megahertz to a 900 megahertz transverter. You may be off frequency. Now you got to calibrate, right? SDR-based radios such as the Apache Labs, the ELAD, and the Sun SDR2 have external reference inputs, which is what you would hook to this. The Flex radios have a GPS antenna input. I assume they have the option built into the radio. So Flex radio, although I've never touched one before, may have this, something like this, their own model, in the radio. And what you do is hook up a GPS externally, a GPS antenna. And it's going to probably self-calibrate and get your reference on point. Does this make sense so far? And if it doesn't, leave the comment below and tell me how way off I am, all right? So it's very simple. I mean, this is what this is. And low noise GPSDO quad clock source, 0.16 to 200 megahertz. So in the manual, there's a lot of interesting information that will show you about PLL settings, hold and run modes, Arduino serial plotter. By using the serial plotter function of the Arduino IDE, you may visualize the behavior of your phase locked loop. All right, time lab interfacing. To plot the frequency data. You can get all this information in the manual. It's got good stuff. Now, to get really on point and show you exactly who would need this and who doesn't, okay. If you have a radio that you're using for weak signal modes using FT8 or moon bounce or even satellites, would you need this? I can work a satellite with a Baofeng, but moon bounce is the final frontier. I mean, you got to be on par with your time and your frequency in order to compensate for the delay there and the frequency that may be changed on the way there and back. You know what I mean? The offset. Because there's Doppler shift, right? You got Doppler shift. Can this help with Doppler shift? Yes. If you have an Elenco DX SR8T and you're on 20 meters on a net in the morning every day on sideband, probably not going to need this. If you have a Baofeng and you want to get on the local repeaters as a new technician, do you need this? No. If you want to get on CB radio on a radio that's not designed for CB radio, would you need this? That's a funny thing. Well, if you're modding something to use on CB radio and it's not designed, the frequency's off, maybe, but probably not. Probably not. A Cobra 29 LTD? No. A Flex radio? No. Because the Flex radio has it built in. You just need an antenna. An Apache Labs? Maybe. Is your Apache Labs on par with the exact frequency? Probably very close. Do you want that extra stability and, you know, what's the word I'm looking for? Here's a better example. Rob Sherwood, who is probably light years beyond anything else. I wish I was a hair on his you-know-what, okay? Dude is smart. Do you think he uses an external reference input to calibrate his test gear? Probably does. Probably does. Whether he calibrates the stuff, I never met the guy in my life, but I know that when he's doing these tests of the Yaesu FTDX101 and the 7300 and all that, he doesn't have eBay stuff, man. This guy's got very precise and accurate test equipment. Could you make accurate and precise test equipment with something like this? Yes. Yes, you could. So hopefully this gives you an idea of what this is for. Now, my 7100 ICOM does not have a way to use something like this. I don't think. It's under my seat in my truck. My 9700 did, and I probably could have used this to get that 9700 perfect for moon balance. Okay? So this video's went on far too long. Comes with a USB cable. Okay, USB connection cable. Can interface with the Arduino IDE app. Power source, the GPSDO, the antenna, which is an SMA that goes in the front, and the manual. That's about what you get with it. It's up to you to decide if you need this, depending on what you do with ham radio or what you do. Again, you don't have to be a ham radio operator to even consider this. Are you making circuits and developing circuits? Here's a good example. Hashtag Mr. Carlson's Lab. I guarantee Mr. Carlson's Lab, who is far light years beyond my education will ever be, knows exactly what he would do with this device. And I can tell you exactly, Mr. Carlson, someone tell him, I'll get Gigaparts to send this to him. When I'm done with it, please do a better video than me and show me what I did or did not do, and educate me, Mr. Carlson. This dude is, whoa, his brain is just huge. This guy's so smart. I mean, he can look at schematics, but well, that's the problem. We're going to fix this in the factory. You should have done that. I'm not sure who was on staff that day. That shouldn't have been done. And in this schematic, this here, and when you open this up, that needs to be fixed. This dude is just, boom. He would appreciate a GPS-based time source like this. He would. Okay? So if somebody can get a hold of Mr. Carlson's Lab and have him watch my video so I can at least tell him, hey, dude, you can give a better explanation than I am. But at least you understand the Rigexpert Tokenblauser. Not for everybody, okay? Not for me at this moment. One day when I finally get another 9700, I had to sell all my stuff to buy my house. I was in bad times, bought this beautiful house, but the radios I could buy again. This house is a one of a kind, so I had to do that. So there you go. Did I ramble enough? Hey guys, thanks for watching, and check out in the link below my other channel that I started years ago and I kind of faded out on, the Ponderosa. Check out the Ponderosa because I threw a few videos on there from this channel where people say, oh, what does beef jerky have to do with ham radio? No, it doesn't. but I thought someone would be interested. I have people over there that are interested on that channel because now we're going to make videos on whatever I want. Could be a ghost pepper. It could be my 3D printer. It could be how to change the carburetor on your generator. We don't know, but it's going to be on that channel. The link is in the description. It's time to ramp that back up. So thanks everybody for watching. Thanks Gigaparts for letting me borrow this. I'm going to send it back. And hey, 7-3 everybody.
Ham Radio Concepts is brought to you by HamRadioPrep.com. It's never been easier to learn about ham radio before you take the exam. And Ham Radio Prep makes it fun and guarantees your success. Visit HamRadioPrep.com. Use the code ERIC20 to instantly save 20% off every course you buy. Remember the name, HamRadioPrep.com.